Okay, so this was on, again, page 53. Okay, this is numbers 2 and 3 on page 53 again. The whole point here is to introduce you guys to logarithm properties. All right, so if we do these problems, hopefully the logarithm properties will come out of them, and then we'll write them down and have them for the test. So number 2A here, our whole goal is we want to see how we can construct 6 from 2 and 3. So for A, for instance, how do 2 and 3 make 6? Multiply them together. So if we multiply 2 and 3 together, we get 6. So that means if we multiply 10 to the 0.301 times 10 to the 0.477, that should equal 6. So I'll go ahead and do that. 10 to the 0.301 times 10 to the 0.477. That equals 6.
See, I wouldn't have thought to do that.
Wait, why?
Because
3 times
2 times 3 is 6, and these equal 2 and 3, so they equal 6. So when you multiply these, what do you do to these exponents? You add them. So you'd have 10 to the 0.778 equals 6. So what does x equal? 0.778. Okay. B. Now we want to use either 2 or 3 or both to get to 8. Any ideas of how we can do that?
2 to the 3rd power.
2 to the 3rd power equals 8. So what I can do is I can take my 10 up to the 0.301. That equals 2. If I raise both sides to the 3rd power, it'll equal 8. Clarice? Nope. So if I raise both of these to the 3rd power, are we okay that that would equal 8? So we'd have 10. Now what do you do to that exponent?
Multiply.
I'm not sure I put a decimal right there. Multiply. So we'd have 10 up to the 0.903 power equals 8. So what does x equal? 0.903.
Wait. Oh, okay.
Okay, so once again, I took 2 to the 3rd power. So therefore, I took the 10 to 0.301 up to the 3rd power. And then I just multiplied those, and I got the exponent there. All right. C. That one's, I think, pretty straightforward. I have 2/3. And how would I get 2/3? Just divide those. So if I do 10 to the 0.301, that equals 2. Divide that by 10 to the 0.477, that equals 3. That should give me 2/3. So now when you have the same base with the exponents, what do you do to the exponents? Subtract them. So when you subtract them, you would get 10 to the negative 0.176 equals 2/3. So what does x equal? Negative 0.176.
How are you supposed to do that without a calculator?
And the last one for D here, D, you're not even really using those problems because 10 to what power is 1? 0. So 10 to what power equals 1? Well, x has to equal 0 because anything to the 0 power is 1. Okay, so now we're looking at number 3, which we've used this book long enough. Usually when they do those back to back, there's definitely a correlation between the two. So now what we're looking at is we want log 6. Okay, now remember that we're talking about exponents here. So if I want in fact, if I go back to the previous problem anyways, what is the definition of this? How can I rewrite this in terms of exponents?
2x.
Not 2x. 10.
10 to the 0.301 equals 2.
So this up here is the exact same idea. 10 to the 0.301 equals 2. You're saying the exact same thing. Okay? So when we go straight to log 6, I know that log 6, that's going to equal log of 2 times 3. Okay? Now when we multiply exponents, or bases with exponents, what do you do to the exponents? You add. So we can actually separate these two, same thing we just did, and go log 2 plus log 3. And that's a property they're trying to teach there, is because logarithms are basically exponents. When you multiply bases with exponents, you just add the exponents. So we're adding the exponents there. And log 2 we already have the answer to up here. Log 2 is 0.301. Log 3 is 0.477. So your answer is 0.778, same as the last problem. B, we have log of 8. What did we do to get the 8 in the last problem? 2 to the third power. So log 8 is the same as log 2 up to the third power. Now remember, I've already talked about this before, but what can you do with the exponent on a logarithm? You can move it out in front and multiply. Okay, you can move it out in front and multiply. You can think of it that way. I just think of it as you go 3, move that in front, log 2. And that's the property we're using. But if you think about what we did in the last one, what we did was we have, or you think about it this way, you have log 2, right? And you cubed it, log 2, times log 2 times log 2. That's 3 of them. Put that out in front, 3 log 2s. Okay? And then we have 3 times log 2, which is 3 times 0.301, which is 0.903. The same thing we had last time. And that's the second property we're going to talk about here. C, same idea. What do you think? We have log of 2/3. How do you think we're going to solve using those log properties up there?
301 over 0.477.
Close. You wouldn't divide them though. Subtract them. Remember the last one when you had the exponents? They're exponents. So when you divide exponents, you subtract them. So you just do log 2 minus log 3. So we're kind of discovering the properties. I'll talk about the properties here in a second, but that's what we're doing with them. Log 2 is 0.301 minus log 3, which is 0.477. We had the answer in the previous one, which is negative 0.176. And then D just says log 1. And again, whenever you have log 1, what is this asking? It means 10 to some power equals 1. What's the some power there? 0. Questions there before we go out over the, formally go over the log properties? Okay, so there are 4 log properties that we're talking about. Okay, the first one is our product property, which basically just says if you have log, I spelled it wrong, logarithm, log base b of x, y, that's going to equal log base b of x plus log base b of y. So that's your product property. Okay, again, within a logarithm, and you can use this on your test, but within a logarithm, if you multiply two things together, then you can always separate the logs into two different logs and add them. Okay, second log property we were looking at was if you have log base b of x to the a power, that equals a times log base b of x. Okay, I just call that the move it out in front property. If you have an exponent on your logarithm here, you can just move it out in front and multiply.
Is it really called?
No, it's called the power property. If you have a power on there.
Do you need to know all the names of them?
I would mean, for me, usually I don't use a name so much. As long as you know how to use it, then I'm okay with that. Okay, your next property is your quotient property, which is your division. So if you have log base b of x over y, that equals log base b of x minus log base b of y. And remember, you can go back and forth here. They are equal. Last property, which is really nice and easy. If you have log base b of 1, that means if you have anything up to what power gives you 1? 0. Okay, questions on log base b of 1 equals 0. So anything to the 0 power is 1. Little side note.
Anything to the 1 power is 0.
Anything to the 0 power is 1. Our note would be that we're assuming here that b is always greater than 0. So b is not going to be a negative power. Or sorry, b won't be a negative. Our base won't be negative. Our base also won't equal 0. It's always going to be a positive number. It's going to be greater than 0.